Welcome again to today's class. We want to see how to name acyclic alkane or alkynes. Why we call them alkenes and alkynes is because both of them are unsaturated. We want to see how to name any alkane compound or alkyne compound, that is any unsaturated compound. Unsaturated compound simply means compounds that have double bond, triple bond. That means they have pi bonds in it. So that makes them to be what? Unsaturated. That is, they can go into reaction very easily. Let's see how to name them. First rule, number the longest carbon chain so as to give the point of unsaturation, that is double bond, the lowest number. So that is the double bond or triple bond, the lowest number. Welcome again to today's class. We want to see how to name acyclic alkanes or acyclic alkynes. Note that acyclic alkanes or acyclic alkynes, they are unsaturated hydrocarbons we have. That is, they have double bond. If we talk about acyclic alkane, it means it has double bond. If we talk about acyclic alkyne, it means it has triple bond. That means they are not cyclic. They are not in cyclic form. That is why we call it acyclic. That is, they are not in cyclic form. Now, why do we call them unsaturated hydrocarbon? It is because they have pi bond in it. For this one that have double bond, it means in that double bond, one will be pi bond, the other one will be sigma bond. In this one that have triple bond, it means it has two pi bond and one sigma bond. That is, they can go into reaction very easy. So let's see how to name them. Rule number one says number the longest carbon chain so as to give the point of unsaturation, that is either the double bond or triple bond, depending on what you have, the lowest number. Now let's see. The rule number two also says regardless of the substituents, numbering is done to give the point of unsaturation the least number. That is what this said. And the substituents numbered similarly, ensuring that each substituent gets the lowest number possible. Let's see what we mean. In this, the longest carbon chain is 1, 2, 3, 4, 5, 6, 7, 8. But this longest carbon chain, does it accommodate this double bond we have? No. Note that this double bond you have in this compound made this compound not to be alkane, not to be a single bond organic compound, but a double bond. And so we shouldn't number straight, because numbering straight will not give any number to this double bond, which is the main parent compound this is. So this is from alkane because of this double bond. So we have to number so that it will take care of this double bond. Now I can number now 1, 2, 3, 4, 5. And someone can also number 1, 2, 3, 4, 5. Another person can number 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have seen all the ways we can number. The first way gave us 8, the longest, but didn't accommodate this double bond. The second way said 1, 2, 3, 4, 5, 6. It accommodated the double bond, but it's giving this double bond 5 because the first carbon carrying this double bond, this carbon, if you are going like this carbon where this double bond is located is the one carrying this double bond. So carbon 5 is the one carrying this double bond, not carbon 6. Now if you follow this way, 1, 2, 3, you now see carbon 1 carrying double bond because you are moving this way. Carbon 1 is carrying the double bond. 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You now see that the direction that will accommodate this double bond and give this double bond a lower number is this direction. That is this direction. Where you say this is 1, this is 2. So this one is the one automatically carrying this double bond. So we now say, since it is this direction, we say 1, 2, 3, 4, 5, 6. 6. When the carbon chain is 6, we call it hex. We call it hex. Okay? So we now say hex, hex. This is hex. That is hexene from hexene. This is hex. Now hex means 6 carbon what? Compound. Now when we follow this way, this will be called your what? Substituent. This will call your substituent. And this is 3 carbon. 3 carbon compound. CH2, CH2, CH3. And this is what we call propyl. This is what we call propyl. Propyl is located where? This is carbon 1, carbon 2. So carbon 2 is carrying propyl. So we call it 2-propyl. I will now say 2-propyl. 2-propyl. Now the double bond is located at the first carbon because we are moving like this. You can't first carbon before you see a double bond. It means that that first carbon is carrying double bond. Double bond is located at the first carbon. We now say 2-propyl because you lost 1 hydrogen atom, which supposed to make here 3. So when you lost 1 hydrogen atom, we have CH2 here. So what we call is 2-propyl. Which carbon carry the double bond? 1, carbon 1 hexane. 2-propyl, 1 hexane. Or you call it 2-propyl hex 1N. 2-propyl hex 1N. That means you are telling them that this double bond is after the first carbon. So we have seen the two names you can give to it: 2-propyl 1 hexane or 2-propyl hex 1N. Now we come to this. We can number it this way: 1, 2, 3, 4, 5, 6, 7, 8. Now note that there is nothing written here. It means that here I have methyl group. That is the meaning. It has methyl group. Another person can number it this way: 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now you now see that if you follow this way, this carbon here is the one carrying this double bond. 1, 2, 3. This carbon here will be the one carrying this double bond. Whereas when you follow this way, this carbon here, which is carbon 5, if you follow this way, 1, 2, 3, 4, 5, carbon 5 will be carrying double bond. Question now is, which one should we follow? Number the longest carbon chain so as to give the point of unsaturation the lowest number. So we need to give this point of unsaturation, which is double bond, a lower number. This carbon 3 is the one carrying it following this way. So if you follow this way, 1, 2, 3, carbon 3, which carry the double bond, will carry 3. But if you follow this way, carbon 5, which carry this double bond, will carry 5. So we follow this way. We now say that we will be having 3. This 3 is for this double bond. 1, 2, 3, 4, 5, 6, 7, 8. 3 or 10. Or 10. Odd means 8. Or you put it this way. Odd 3 in. I've taken care of the what? The double bond. Now I am to take care of the what? The substituent. Still with that direction. 1, 2, 3, 4, 5, 6, 7, 8. The substituent will be 3 and what? 6. That means I will have 3, 6. Since the substituents are the same, 3, 6 dimethyl or 3 in. 3, 6 dimethyl or 3 in. Or 3, 6 dimethyl 3 or 10. So we can have the name this way. Now we now say let's name this. So name this, we number 1, 2, 3, 1, 2, 3, 4, 5, 6. This one, this carbon 3 is bearing this double bond. 1, 2, 3. The carbon 3 from this side will also bear the double bond. When you number it this way, carbon 3 is bearing double bond, but the branches are 2 and at 4. 2 plus 4. But when you number this way, 1, 2, 3, 4, 5, 6. You see that the carbon 3 following this way will bear the double bond, but the branch will be located where? Carbon 3 and also in the carbon 5. That is 3 plus 5. This is 8 and this is 6. So following this direction, you see carbon 3 and carbon 5 bearing the branch. Following this direction, you see carbon 2 and carbon 4 bearing the branch. We say, since both of them are having the what? The same point of saturation as point 3 and point 3. We will take this one that gave us a lower sum of the branch. That is like this. That is like this, right? This is 3 and 5. No. This direction we will not follow it. We will follow this direction because this is 2 and 4. That means I will have 2 bromo. 2 bromo. This is 2. 4 methyl. 4 methyl. Then, after writing that, what I will now write is, I've taken care of the branches. I will now say 2 bromo, 4 methyl, 1, 2, 3, 4, 5, 6, hex 3 in. 3 means that the point of unsaturation, that is the double bond, is located after the 3rd carbon. We say 2 bromo, 4 methyl, hex 3 in. Why I started with bromo is because B comes first before M. If not, I would have said 4 methyl, 2 bromo, but because B comes first before M, I said 2 bromo, 4 methyl, hex 3 in. So that is how to name this. We go to the last one. Now please remember that as you see hex 3 in, it's the same thing as you saying 3 hexane. 3 hexane. 2 bromo, 4 methyl, 3 hexane. Hex 3 in. Both of them are the same. Now coming to the last one. You see double bond, you see triple bond, and you see methyl group. If you number this way, that means that this compound is alkyne alkyne, that is triple bond. This triple bond will supersede the double bond. It's from alkyne group. That means if I number this way, 1, 2, 3, 4, 5, 6, 7, 8. This carbon following this way, carbon 5, will be bearing this triple bond. But if I number this way, 1, 2, 3, this carbon 3 will be bearing this triple bond. 4, 5, 6, 7, 8. So this carbon 3 will be bearing this triple bond, which is the parent carbon compound, or which is the parent compound we are talking about, that is iron. And also, if you follow this way, this substituent will be given the lower number, that is 2. So what we will now say is that the name will be, the name of this one will now be, we say it is 2-methyl, because if you follow this, so we'll give this triple bond lower number. 2-methyl, 2-methyl, or 2-methyl. What is the longest carbon chain? 1, 2, 3, 4, 5, 6, 7, 8. 2-methyl, or where is the triple bond, double bond located? Because double bond will come in first before the triple bond. 1, 2, 3, 4, 5. 5 in. Then where is the triple bond located? 1, 2, 3. 3 I. So that is how to name this compound. Okay? This is how to name acyclic alkenes or alkynes with even branch. Thanks for watching the video.